Welcome to this Forces and Motion revision session from the P3 unit. By the end of this session you should be able to do the following three things. Firstly, you should be able to describe how forces change the motion of objects. Secondly, you should calculate the force using mass and acceleration. And finally, you should be able to rearrange the equation from above to calculate mass and acceleration. Right, so there's two key words that you're going to need to know. Firstly, mass, and secondly, resultant force. I want you to pause this slide and see if you can write a definition for these two key words. Now you've had a chance to write your definition, let's see what it actually is. Right, mass is the amount of matter in an object, and this is measured in kilograms. Don't forget, when you're writing kilograms and using the symbol, this is a lowercase k, so kg both lowercase. And the other one that you'll need for the higher tier is resultant force. And the resultant force is the sum of all the forces on an object, taking their directions into account. Right, so when an object is moving, it's going to carry on moving exactly the same way until you impart an external force on that object. So what I want you to do is I want you to watch this video here. Again, like all my normal slides, you're going to have to find that YouTube clip yourself, but I want you to think about the three things that are on the left. I want you to think about how the force makes the object change its motion, and the idea in this video of whether it's the change in speed or the direction or both. So watch the video and decide how the external force which has been applied to the man has changed his motion. Right, before we move on, we're going to have to see if you can remember the definitions of two words that we've done earlier on in this P3 unit. The two words that you need to remember the definitions of that were earlier on in the P3 unit were velocity and acceleration. So now I want you to stop this slide and see if you can write down a definition for these two key words. You're going to need them for this as well as the other ones from the start of the slideshow. Right, now you had a chance to write your definition for velocity and acceleration. Let's have a look at the real definition. So velocity is speed in a given direction and acceleration is a change in velocity. Therefore, if you think back to that video, when the external force is applied to an object, it changes the speed or direction, and a change in speed or direction, i.e. a change in velocity, here is acceleration. So applying an external force to an object is going to cause it to accelerate. In the case of the man on the video, when he ran into the road sign, that was a force that was acting against his motion, so it caused him to slow down, so that's a change in his speed, and it also knocked him from his feet, so he stopped running to the left and he was laid out on the ground, so it also caused him a change in direction. Of course, this effect might have been different if the man was heavier or lighter. If you apply the same force to heavier or lighter objects, this is going to have an effect on how much acceleration and the rate of acceleration it's caused. So let's have a look at how that works. So applying the same force to different objects causes this difference in the rate of acceleration, and the biggest factor of that is the mass. The greater the mass, the slower the rate of acceleration, and the smaller the mass, the greater the rate of acceleration. So think about it in terms of this way. If you've got the same powerful engine and you put that engine into a truck, a car and a motorbike, which one of those is going to have the greatest rate of acceleration? Right, and there's your proof. So we've got the same engine in these three vehicles. You know that because the forward force that's being applied is exactly the same. Here's the mass of those vehicles. So as you increase the mass, this is going to accelerate slower. So if you increase the mass, you've got a reduction in the rate of acceleration. The lower the mass, the greater the rate of acceleration. Now, of course, we can actually calculate this. So we're going to look at how we calculate the force given the mass and acceleration like we had there. Okay. It isn't about Darth Vader, but he was pretty powerful in the ways of the Force, so I'm pretty sure he could move these objects just as he did in the films. So let's have a look at the equation. Right, here's the equation. Force is mass multiplied by acceleration. What I want you to do now is I want you to pause this slide and I want to see if you can rearrange this equation in order to give you mass or acceleration. I'm going to suggest that you're going to want to put this into a triangle. So pause the slide and see if you can get what's in each of these three areas. Okay, so here is that triangle, and let's hope you've got it right. And as with all of these triangles, you cover up the thing that you're trying to find. So if I want to find the mass, then I cover up mass, and that gives me force divided by acceleration. If I want to find the force, I cover up force, and that is mass multiplied by acceleration. And if I want to find the acceleration, that is force divided by the mass. Just like with all of these calculations, they're going to give you this equation in the exam paper, but of course they're only going to give you that version, and you need to be able to rearrange like this. On the next slide I've put two worked examples, and make sure when you look at those worked examples that you are clear with what they mean. If you're not clear, then maybe you need to come and find me or one of your other science teachers so they can explain it, because you never know which version of this equation you're going to have to use in the exam. So let's have a look at the two worked examples. Right, the top one is asking about the force. Cyclist accelerates at 1.5 meters per second squares. The mass of the bicycle and the rider is 90 kilograms. What is the force? So of course we're going to use the normal equation, F equals ma, F equals m times a. We know the mass, which is 90 kilograms, and we know the acceleration is 1.5. So if we multiply those two together, that gives us a force. And don't forget our units, which is newtons. The second one, this is the sort of question that's likely to put people off. You're going to look at all these noughts here and you go, well, I can't do that because there's all these noughts. Well, it doesn't matter, because as long as you know how to do the equation, you can put numbers of any size in. So if you start with force equals mass times acceleration, that's fine, that's the one they're going to give you, but it's asking you to calculate the acceleration, so you need to rearrange that equation. So acceleration equals force over mass. Here's the force, we know it's force because it's measured in newtons, and here's the mass, which is in kilograms. Notice it's a lowercase k for kilograms, so all you do is you divide 800,000 by 320,000 and it gives you the acceleration. And don't forget the units, it's acceleration, so it's meters per second squared. That squared is really important, and don't forget on the exam paper this can also bring you extra marks. Right, now we're going to move on to resultant force and how this affects acceleration. Okay, when you've got more than one force acting on an object at a time, if these forces are balanced, i.e. they're the same size force but acting in opposite directions, then the object stays stationary or moving at a constant speed. If you've done the P3 unit towards the end, you'll have done terminal velocity, and obviously this is where you've got an object falling where you've got a downward force and you've got air resistance that are the same size, and terminal velocity is a constant speed. So just because this air resistance and this downward force are the same size doesn't mean the object stops, it just means it falls at a constant speed. Okay, so here on this car you've got a forward force going to the right that's been applied by the engine of the car, and you've got a force acting in the opposite direction, that's friction of the wheels and air resistance as air is hitting the car. But look at the size of the arrows. These two arrows are the same size, which means the forward force and the force in the opposite direction are the same size but in opposite directions, so this object is moving at a constant speed. This of course is different if the two arrows and the two forces are different sizes. So let's have a look at the next. So in the one you're about to see now, the forces are unbalanced, they're different sizes. If this happens, the object is going to accelerate or decelerate. In this case, here's your forward force being supplied by the engine, and here's the force working in the opposite direction, which is the friction on the wheels and the air hitting the car. As this force working against the engine is greater than, as you can see by the bigger arrow, greater than the forward force, this car is decelerating. Right, and now it's time for a question. Right, so in this question, I'm going to push a car with a force of 500 newtons, and someone else is pushing the other way with a force of 400 newtons. And there's two things I want you to do. I want you to see if you can calculate the resultant force, so this is the overall force, the difference between the two, and draw a force diagram to represent the motion. So I want you to stop this slide and see if you can do those two things. Firstly, calculate the resultant force, and secondly, draw a force diagram, and then we'll look at the answer. Right. To the first answer, what is the resultant force on the car? There you go, so it's 500 newtons is the force I'm applying. The other one is 400 newtons, you subtract one from the other, and that gives you 100 newtons overall. The second thing you had to do was try and draw this in a force. Okay, so there's 500 newtons being applied in one direction, and there's 400 newtons being applied in the opposite direction. So that's a force diagram. Look at the size of the arrows. The 500 newton arrow is bigger than the 400 newton arrow. Look out for that on exam questions. Right, and now let's have a look at another question about an imbalance. So in this example, the engine of the car in the diagram is providing a thrust force of 1000 newtons, and you can see that here because it's moving in that direction. The friction and drag forces, so the drag forces of course is air resistance, add up to 600 newtons. And the mass of the car is 800 kilograms. What is the acceleration of the car shown in the diagram? So, first of all, you're going to have to work out the resultant force. Having worked out the resultant force, you're going to have to rearrange the force equals mass times acceleration equation, and that will give you the ability to calculate the acceleration. So pause this slide and do the calculation, and then we'll look at the answer. Right, now you've had a chance to look at the answer, let's see how to work. First of all, you need to find that resultant force. So you do 1000 and you subtract from that 600. So you've got a resultant force of 400 newtons. Well, we know that the mass is 800 kilograms. We've rearranged the F equals ma equation to make acceleration the subject. And so acceleration is force divided by mass. So the force was 400. The mass is 800, so 400 divided by 800 is 0.5 meters per second squared. Now, I did do this as a superscript, but it just hasn't come up like that. Make sure when you're writing it that you do it as a superscript. And because you've had to do a multi-stage answer, because you've had to work out the resultant between those two, and you've had to rearrange the equation, this is likely to probably be worth 2 or 3 marks, but still make sure that you put all your working out in a very clear way, because if you get your answer wrong and you've not got any calculation in, you definitely get 0. If you get some of the calculation right and then for some reason you get your answer wrong, you never know, you still might pick up some marks. Well, that takes us to the end of this revision. You should now be able to describe how forces change the motion of objects. You should also be able to calculate the force using mass and acceleration, and finally you should be able to rearrange the equation in order to calculate the other two things, i.e. mass and acceleration. And as you are always keen to know what's going to come next, let's have a look what's still going to come in this series. There is still going to be a revision session about the factors that affect the stopping distance of a moving vehicle, and then we'll move on from that to look at work and power. So thanks for tuning into this revision session, and I hope it's helped.